Guys, welcome to the webinar today. We're going to have a very informative webinar about fiber optics. So you can call this Introduction to Fiber or Fiber 101. My name is Ricardo Flores. I am the product engineer for fiber and fiber accessories. So I'm gonna teach you a thing or two about just what is fiber, how do we use it, and like the most basic type of installation. So let's go into it. So this is our little syllabus for today. So we're gonna touch upon all of these points. So we got intro to fiber optics, pros and cons, installation environments, diagrams and elements of FTTX network. FTTX just refers to fiber to the home. Well, fiber to the NDX is just home, hotel, a city. Like you can mix and match, like depending on your application or your projects. We just use FTTX to refer to like the whole application of fiber. And all right, so let's start with the most basic thing. What is fiber optic, or what is optic fiber? So, um, in the most simplest terms, tra fiber, it's basically the size of a human hair, and it's just glass. So silicon dioxide, it's what happens to sand when it's baked at really high temperatures, and you remove all of the impurities, you end up with a really fragile like glass. So what do we use this glass for? Well, it's a transmission medium that we use to send wavelengths that are not visible to the human eye. So when you're doing fiber, do not look directly into the material when it's transmitting, because even though you cannot see it, it can damage your retina. So in the light spectrum, um, there is a lot of lights that the human eye is not capable to see. We can only see like the color spectrum, the like colors from magenta to red and anything in between, but there are a lot of other signals that the human eye cannot actually see. So let's be very careful with that. So when buying fiber, you probably seen this um, single mode and multi-mode or mono mode. These are different types of fiber, and this is just a diagram that shows like diameters. So at the moment, OM1 and OM2 are obsolete. So we're actually using OM3, OM4, and OM5. That will refer to multimode fiber. And you can see the size of the, let me show you. So you can see this is the core of the fiber of the multimode, and this is the jacket. So the core is 50 micrometers, and the fiber jacket is 125 micrometers. And when you go into single mode, it's 9 micrometers, and the rest of the jacket is 125. So the difference between the size of the conductor, or in this case, the fiber wire, it's referent to the amount of imagine it as if like a copper pipe that takes water. There's higher pressure when there's less area. So in this multimode fiber, the light signal, the light source will bounce around and you will have loss. And that translates to less range when you're transmitting data. And this smaller conductor uh, conserves the power of the signal better, so it will give you more range. So most type of applications, you are You can use like single mode or multi-mode, but it's very dependent on the range. So for longer distances, we always recommend single mode, and for buildings like small installations in offices, multi-mode works perfectly. So yeah, let me show you what I was explaining to you. Like you see in multi-mode, you have the light bouncing around because there is more space inside of the core conductor. And in single mode, you can see it's way smoother and it will give you more range. Even if you have like a graded index where you have less loss, it's more it's a better finish. You still have light bouncing around that will generate loss at longer distances. So you probably heard also about tight buffer and loose tube optic fiber. So sorry, this one's in Spanish, so I'll just talk a little bit about it. So in the loose tube environment, um, it's better to have like a loose buffer when you're doing outside installations that it's very dependent on weather elements. So heat and cold are influential in the installation of fiber. If you have like a tight buffer, you can see like you have your jacket. It's it's you have a jacket and on your fiber, and you have like other stuff like on it. So when you're being affected by heat or cold, the wire can contract. So if it gets too hot or too cold and if it's very tight, your fiber might break and you might lose connection. It's something that can happen. So you can see like on image C, you have here how it's contracting due to low temperature. And if you have your also in your installation, if it's very like tight, like you don't didn't leave any space for the fiber to just dangle a bit. You have it very tightly installed. When the fiber from the inside contracts, it can break. Okay, so let's talk pros and cons about fiber. So let's start with the pros. Uh, Fiber doesn't use electricity to send signals. It's just a light source. So you're immune to electrical interference. So it's safer when doing installation. Uh, it gives you greater speeds and than other transmissions methods like copper. It's smaller, so it requires less channeling space. So it's good for offices or cramped spaces where there's already a lot of infrastructure like copper. You can put it next to the copper, and because uh, it doesn't carry any electrical signals, it's immune to electrical interference. It's high density and it has a large product lifespan, 20 years plus. So what are cons? So you require special equipment to convert these electrical signals to optical signals. It requires special equipment for the installation process. You require training to manipulate this fiber. It's not as easy as doing like copper, and it's not that well known. So there's not a lot of people that install fiber or that know about fiber. Is quite like a new technology, right? And it does not transmit electrical energy, so you don't have PO installations. Like if you run a fiber to a standalone site, well, you cannot power the devices with the same wire. You need to find other ways to power your equipment if you're running fiber. Okay, so let's talk a little bit about installation environments. So you have indoor installations, you have installations in tray or tube, um, dielectric and flame retardant for like indoor offices and other applications where, well, you need to certify that, hey, our fiber, it's good for indoor. It will, if it burns, it has a flame retardant, it's non-toxic. So it's like a most basic indoor installation where you go from the equipment room to telecommunications closet and install it each and every way. So let's just jump right to the fiber. I think you guys know mostly like about indoor installation or off installation and what you require for there. So fiber is standardized by the TIA 598C standard. So it's color coded now. What's been color coded for a couple of years. So at the start, we had OEM 1 and OEM 2. That was multimode fiber. It was orange. This one's obsolete. So no, you can still buy it, but as I'm telling you, it has a high loss. We have a better we have better options, OM3, OM4, and even OM5. So this multimode fiber optic, it can give you like 10 gigabits of laser optimized data, and OM1 and OM2 do not go up to 10 gigabits. It stays in gigabit, and it doesn't have that good of a range. So if it doesn't give you 10 gigs, then you're better off just installing Cat6 copper uh, cables instead of OM1 or OM2. And you have the single mode fiber that is OS1 and OS2. And also drop fiber is also like single mode under this category. So you'll get into drop fiber later, but where you're looking for fiber that your clients like, oh, we want to install like single mode or multi-mode indoor, like, oh, I need like this aqua jacket. It's like you know what to look for just by the pictures. You don't have to like go on 3 on 4, just, oh, I need like jello or I need like aqua, and you go like through it and, oh, here it is, and just confirm the information. But it's already standardized, so it's easier just to go by the colors. Or if you're talking with a client about what he wants to do, you can take a look at the telecom room and see what kind of fiber he needs based on what he already has installed, or maybe give him a suggestion. All right. Drop fiber can be installed indoor and outdoor. So installation in trays, exposed, or in ducts. Um, because it's also for outdoor, it has UV ray protection, and the material is usually PVC or LDPE jackets, this black jacket for outdoor. Um, when we going into direct burial installations, the fiber we recommend here at AppCom for this type of installations, it's LPGIFS. It's armored fiber, so it's shielded. So when you install it on underground, you don't have to worry about having like a tube where you install it. You can like bury it directly on the ground. So it has MDPE or HDPE jackets. What does that mean? It's medium polyethylene and high density polyethylene jacket. So it just means like a medium density plastic or high density plastic. So it can be single or double, and we carry like the LPGIFS is shielded fiber for underground installations. Yes, it's a little bit more expensive. Yes, it's more expensive to get permits to go underground, but for some installations like residential, it's required. It's well, not required. It's better to go like underground to keep like clean installation, better look for the community and stuff like that. So yeah. Um, this is the most popular type of installation, aerial installation. So we have MDPE or HDPE jackets as well, like medium density, high density. It goes shielded and unshielded. Um, the most popular one is unshielded. So this is the popular one, the unshielded version, because it's lighter. So when doing installations on the air, it's easier for the installers. It's also a cheaper price, so it keeps your costs down. But you run into a problem. Why do you need shielded aerial for your installation? Well, in areas where they have rodents, rodents like squirrels. Squirrels are known for biting cable, so you could have problems with rodents interrupting your data center, your data sites, your data flow when they go in and they bite on unshielded aerial drop fiber. So maybe on those types of scenarios, you can consider buying shielded um, fiber just for rodents and stuff like that. So so we have LPOC ADSS fiber for and also mini fiber for aerial installation. It's the most popular type of installation of fiber. You can see it like anywhere in the city. You can see like the cables and also the figure eight drop fiber. It's for aerial installation because, well, as you can see, figure eight, it has a little steel messenger right here. So this steel messenger gives some rigidity to the fiber. If it didn't have it, the fiber will break under its own weight. So if you're doing aerial installations of drop fiber, you need like a steel messenger. There are occasions where you can ask like, why do I need I only have drop fiber without a steel messenger. It's only like this section. Well, for those types of scenarios, you need to go like on the ceilings, on the walls. You need to route it somehow, give it some support because it will break if you don't support it with something else. So yeah, let's go to air installations. How do we determine the span? So the span is the maximum distance between two posts. So you can see here, like we have one post at 80, one post at 50, one post at 100. So the span, it's the maximum span, it's 100 meters. So we should calculate like, we should buy a fiber that can give us like this span. As you can see, we have a mini fiber that the span is 80 meters. Will this work here? Well, here and here, yes, you're fine here and here, but not here. If you try to do like maybe in the best scenarios, we can give you like maybe it goes up to 90 meters. But if there's wind, if it gets cold and it's too tense, maybe the fiber can break. So let's always just go like with the span that the manufacturer is like recommending, because after that, maybe you can do it. Maybe it has worked for you, but if it breaks, well, the manufacturer and we cannot help you because, well, we are telling you like the span is 80 meters that we recommend. If you go like further than that, then, well, it's out of our recommendations, out of our scope. We cannot help you with those types of issues. So instead of using like this mini fiber, we will recommend using like the normal one for this scenario. Okay, so let's show the diagram of FTTX networks. What is fiber to the home or GPON network? So fiber to the home, it's just A fiber installation that is designed to go to the homes from the ISP, which will be your internet provider, through the city, through the installation, up to your home. And a GPON network is a gigabit passive optical network, meaning a point-to multipoint optical network in which there are no active elements between the main operator facilities, the OLT, and the user terminal equipment, meaning an ONT or an ONU, which is optical network unit or optical network transmission device. So basically, what we're telling you, it's a GPON network or a FTTH network goes from the OLT here, which is an active component. All of the fiber, it's passive. So it goes like OLT to the first division, which is the trunk, to a divider, splitter. So it splits off and it splits again and it gets to another active device, which will be your ONT or your ONU. So for this types of installations, the single mode fiber optic, it's what we recommend because there are like long sections and the single mode will give you the most range. So you have your fiber, your splitters, your connector, your splice boxes, and all of those devices are passive. So you can see like you start here, active, and you go like fiber, passive, connector, passive, a splice box, passive, splitters, passive, and then you go fiber 2, also like splice box and splitters, passive, and then you go to the house and there's another active device there. So how does a WISP network work? Well, in both traditional WISP networks and FTTH networks, we have a point-to-multipoint connection that is made between an access point and its subscribers. So think of it as a PTP related to a PTP device or PTP network that you already know. So um, here you have your access points. So in this case, it's an antenna that's sending the signal to the subscribers and it's just connected into the home. Well, we do the same thing right here. It's just our access point, our OLT, but instead of antennas, instead of like over the air transmission, we just connect everything to a cable and we split it off to all of the subscribers in our network. Okay, so it's a little bit more of explanation how it works. So we have like the internet and we have a WISP right here on our service providers' main offices. So like we have our servers and everything's connected to the switch. That switch is connected to the OLT, and from there we just have our local convergence point, and we split. That's our first level splitter. We split to a building, to houses, to offices, like split to here, and then we have our second level splitter, and from there we split to all of the places we want to go. So when do you use an FTTH network? Well, there are some advantages to it. As you know, the RF spectrum is very saturated, especially in cities. So this is and it's very limited because of the same saturation. The FCC and other uh, organizations that deal with RF frequencies have limited the spectrum and the power you can transmit your data in. So you're limited to a very low speeds. So we have our advantages of providing this type of service and we'll give you better speed, better bandwidth, better distance. You can take many services through the same fiber line, and it's scalable, easy. Well, not easy. It gives you better freedom on operation and maintenance. So, as I was telling you, you have active and passive devices. So, your active devices are the devices that transmit and receive the information, and your passive devices are just like your medium, how you connect your active devices. So your active devices require power, and your passive do not require any power. So let's talk a little bit uh, about this active and passive devices. So you have your pixels and mechanical connectors. So all of this um, passive devices are pre-assembled and help you do like connections. You look at everything that's more suitable for you to connect. So you have and they serve a purpose. These are meant to be like spliced to your fiber, your trunk line. Oh, sorry. To your trunk or your drop fiber. And these are only suitable for tight buffer and drop. So this is mostly at the end of your connections. Okay, so there are also two types. Well, we mostly use two types of connectors, and here at EPCOM we only manage the SC APC and the LC UPC. Well, SC and LC. So previously we had like PC connectors. You can see here the how it's shaped, but there was a bigger loss on your connector polish. So we start carrying UPC and APC. APC is more popular because the loss it's way lower compared to the other ones. You just move like a decimal point. So UPC is popular in office buildings where you don't need um like 0.01% loss on every one of your connectors is not that big of a deal. But for FTTH or FTTX connections, UPC is more popular. You know, you can see how it's angled. So you have less refraction here than on the UPC. Here you can see like in these sections, there can be some loss of light. And this is like a reduced area space. So it's favored by many like WISP providers that do fiber. So also when transmitting CATV over PON networks, the use of APC connectors is mandatory. So you can see how the reflected light signals are the nucleus. So you have it right there. So it's the same principle here. Okay, so our connector types, as I was explaining, SE APC is used in PON networks, PON applications with reduced return loss. But you also have like UPC. It's used in like smaller distances, and it's good in telecom rooms. So when you have you can connect like APC and UPC, but as you can see, they don't mash like pretty well there. So you're gonna have high loss here. Maybe in a small distance, you don't see like any issue. Maybe it works, but on higher distances, it can cause you a problem to have this connection because it's gonna bounce right there. So what does PC mean? physical contact. So UPC ultra physical contact and APC's angle physical contact. You can see it right here in the connection. You have physical contact and you have like a smaller area here. So it's ultra. And here you see the angle of the connection. Okay, let's talk about splitters. There are many types of splitters. You have preconnectorized APC, and UPC, and you also have splitters without any connectors, so you can do your own. But you need like you need pictoles for this one, and you also need a fusion splicer to be able to make your installation here. You cannot come in here and just use a connector like a mechanical connector. It won't work. So splitters allow for a signal input to be divided into multiple output fibers. So when you're doing like this type of installation, you can see like you go from here, you have your trunk, and then you use a splitter through from 1 to 4. And even if you don't use like the 4 lines, you can see like, oh, I'm gonna use this one. So it goes through here, and then you go like, I have like 8 houses there, so now you go 1 to 8. And you can connect like every one of this is like a subscriber. And even if you don't use like this connection or this connection, it's scalable in the future. If you do any other connections, you can take your line from here and do like another 8 splitter. So you can split again. So splitters are very important to a PON infrastructure. If not, you will like need like when from the start where you connect it to the users, you will have to run like one cable like to every one of your subscribers. So splitters are very important for the installation of fiber networks. So fiber splitters usually come, well, usually require like splice enclosures. They allow for the entry and organization of splicing or fusion fibers. So when you're taking your trunk line, you need to divide it. Well, it's a space where it doesn't, you have to peel the jacket from it. So if you go like this, you're gonna have to peel the jacket right here, and you just have like X amount of wires, right? So you need like an enclosure to protect your connections here, and when you'll be able to route, like maybe this is like one spot in your fiber journey, like this is NAP 1. So you take one wire and you use a splitter, like 1 to 4 splitter, and now you have like 4 connections for your users, and you can keep going to the NAP 2 where you have another other like connections to make. So their main function is to protect the fiber from your external agents. So when you're doing like your fusion splices, they're out of the jacket, so they're now vulnerable. So you need to protect them with a fusion enclosure. So it serves like the purpose of protecting the fiber splices and also helps you manage your network. How do you mean like manage? Well, this is NAP 1. You just need like one wire here, and then you continue your journey and you have like NAP 2, and you do your other connection and you can keep going. So, like NAP 1, you have 4 splices, and NAP 2, maybe you have 8 splices. So you can you can manage your network and route all of your wire from here to here and just keep a diagram. So whenever like one subscriber is telling you they're having issues with their network, maybe you need to go there and well, you know where they are located, and you can start like maybe from the box or maybe from the home and work your way back. So there are certain types of fiber splicing closures. You have a dome where the inputs are below you can enter the trunk route through the bottom and just do your connections here and then go through them. So this is usually like a local convergence point. It's like the first level of the splitters before you get to the houses, and you also have like horizontal enclosures. This is what you most usually see like connected to the electrical poles. You have a pole in the city, like the electrical ones, and you see like a little box just hanging there with like a wire inside of it. It's usually this type of horizontal enclosures. They're very popular in the cities. These ones, they're all popular also to like bury when people are doing like installations on residential areas but don't want to do like um, over the air fiber. They sometimes bury this underground. They work great. So from your LCCP, I'm sorry, from your local convergence point, you go to the NAP. It's your network access point. This is like the final step where your fiber, your trunk fiber gets in. You can see like this is your distribution route. It goes in and then you splice it into your drop fiber. And this connectors go into the subscribers' homes. So how do we pick splice enclosures? Well, you need to go by quantity, like how many fusions are you gonna make? Like maybe you want to use like the 8 ones, but you have 10. So instead of using like going for the 10, you should go for the 16. Why not use like a 10 and a smaller one, like or like a 8 and a 4? Well, maybe in some point of the process, maybe you need to scale maybe you have another subscriber or maybe you're gonna need more. So instead of like using uh another box, going sending someone else to do another installation of a box, finding space for the box, maybe splicing it again, you can just go in, splice a drop fiber into the NAP and just carry the cable from there. So always overestimate in case of this devices. You're also gonna need to take into consideration the size of ports and diameter of the fiber optic. So the trunk line is your main fiber, and then you have your distribution, and then you have your drop. So think of your trunk fiber mostly. So also you have installation type, aerial with messengers, wall mounted, pole installation, or underground installation. How are you gonna install the fiber? How are you gonna install uh the naps? Where are they going to go? Are they going to go in poles? Are they going to go in walls? Are they going to go underground? And for other installation, we recommend for aerial at least IP65 and for underground IP68. IP68 mostly for the ingress of water. So it's very important when you're doing underground installations to go into IP68. Okay. Now let's go into the active component. So what is an OLT? Well, as the name suggests, optical line terminal. This is like your light switch. This is where the main fiber cable is sent to the users and is the same one that manages the user's traffic. Each one of these ports has the capacity for 128 users. So this one is 4 ports, so it gives you the capacity for, don't tell me. It's 512, right? 4. Yeah, 512. So it gives you a capacity of 512 users max. But as a recommended practice, we recommend like going half of it, so 64 users per port. So 306, I'm sorry. Uh, it's, it's still early, I need my coffee. So we recommend like 256 maximum users. So 64 per each port. So now we have the types of technologies. So if you see XPON, it means EPON and GPON. Like if you have EPON devices, it manages them, and it has also GPON speeds, but it won't give GPON speeds to EPON devices. So when you're doing splitting, you can go from 1 to 64 or 1 to 28 to 128. And XGS PON technology gives you splitting higher speeds and better splitting. This is kind of a new technology, it's the most expensive one. Most networks are GPON, but we're starting to look into the leap to XGPON speeds and XGPON technology. So, what are ONUs? These are responsible to receive and filter the information being sent from the OLT. So this is the device that goes into the user's home. This is the CPE. So you do your drop fiber, and then you have a little reset here, and you connect it to the user. And this is an Ethernet port. So it's just Ethernet. So you connect it from here to like a router or a modem that gives already like Wi-Fi signal. And there you go. That's the end of your installation. And you can use like several wavelengths to transmit like voice, data, and video. So it goes into only one fiber. So you can do like CATV, you can do like POTS. So when doing PTP optic fiber versus GPON, you have your PTP links that give you greater distance, and you use just a connection between two devices. Uh, this switches have a SFP port on each side. So you're using this are called SFP or mini-GIVIC. We call it mini-GIVIC. And they communicate. Their function is to transmit or convert electrical signals into light. So they're just sending like light through each device, and then when they receive it, they send electrical signals to the switch, and that's how they are connected. But a fiber GPON link, it's has a max distance of 20 kilometers, but it has a point to multipoint connection. So if you're doing just connecting like two sites, this is like the better option. But if you're doing service for many users, a GPON network is recommended. It's better because imagining we're giving to 20 subscribers, we're giving them signals. So from here, you will need like 20 SFP ports. So how many switches you think you need? Most switches have two SFP ports. So maybe you need like, in the best case scenario, you need 10 switches, and then you need 20 switches on this side. When in this case, you just need your OLT and do your configuration. And at the end, you just need like the 20 user devices. 20 onus to give service. Right. So there's a difference between the SFPs. You have duplex, and you have bidirectional, and you also have simplex. So this one's require 2 wires at a minimum to send and receive. You have also bidirectional, so you can send and receive through one wire at the same time using different wavelengths. But you need different transceivers. This one's usually like transceiver A, and this one's transceiver B, and they're color coded. This one you just need like the same one, and they need to communicate like in the same. For example, you have this one's 130 nm, and this one's 150 nm. Well, then you have a problem with the wavelength, and they're not communicating. It's basically like this one speaks Spanish, and this one speaks English. So they're talking different languages, and you will just have a loss of packets. So what are the characteristics of fiber installation? So, well, you need to consider the number of cores, the span, and the the build. For example, all of this, it's exterior fiber. But these ones are aerial. You can see this one's mini figure eight because they have a messenger cable, steel messenger. This one's self-supported, but this one, it's underground because it's shielded. You can see here the shield. So we have site central office, and you have your trunk fiber. This is your main line from your ISP. And here you have a distribution point. You can see how the wires are going from here to here to here and to here. So here you have your local convergence point, which is vertical fiber enclosure. And now you have distribution fiber. You're distributing here, and you have your network access point. And from here, you're connecting to your houses, and you have another convergent access point here. Like, so here, 1 and 2, and 1 and 2, and 1 and 2. So you start on your site, and just, you can see here that you have another trunk here, and then you're distributing fiber to all of these homes back here. So the distribution fiber is drop fiber. Here you have your trunk, and here you have your drop fiber. You can go like from here to here with this one's figure eight, and you have your connections. Your access points are here, here, and here, and just connecting each home. So at the end, when we get to the house, this is a typical drop fiber connection. So you have your reset. As from CData, we manage FD 500 GX, where it works as an ONU, where you take the fiber, you have your set, you have your jumper, and it goes into your ONU device. And from there, you just have your internet. You can connect something else here. Maybe the client has a router, so you can connect just an Ethernet cable from here to the client, and you're done. Or maybe you have another rosette that has two outputs. So you have your drop fiber going in, and maybe you have two patch cords. So you connect one here, and you connect another one here. And now you have two devices connected. So our drop fiber, it's in the standard of G.657.82. So it gives you better resistance. It's more flexible, so it won't break as easy when you're doing like this type of scenarios right here, where you're bending the fiber. It has a greater bending resistance. Most other sellers manage this one, the A1. So what's the difference between 10 and 7.5 millimeters? Well, when you're manipulating the fiber, maybe in like a turn, you turn too much and it breaks. So having like better resistance, it's recommended for most of your installations. Maybe you know how technical people are not as careful. They want to get the job done quickly. So maybe they bend it a little more than they should and it breaks. So now you have to redo that fiber from the access point up to the house. And that's not ideal for most installations. So we recommend like G.67.A2. Maybe if you want to do B3, maybe you can do that. But I think A2 is the perfect um, environment. Okay, so we're almost at the end. This is our last slide. Thank you for joining us. Thank you for bearing with me. So this is the TIA 598C standard. So this is basically telling you how the fiber colors are going to go. So when you're doing um, like when you're doing installations where you have more than 12, more than 6, even about 144 fiber lines, well, this is like the color you should be looking at. So you have it's standardized, so it's always gonna be like this. So you have your blue. You can see here we have 1, 2, 3, 4, and there's 12 cores in each one. So you know there is 48. So which is the first wire? It's the blue one here. Which is the second one? Is the orange one here. The third one is the green, and then we have. I'm sorry, this one's the orange. This one's the brown. I guess I use like the same. It's not very brown. I feel it's like more orange, but yeah, this one's more yellow. But let's say this one's blue, this one's orange, this one's green, and this one's brown. So from the blue wire, you take the blue wire is gonna be the first one, and the second one's the orange, and then the green. So you can like use this standard. So when you're fixing like a trunk line or doing installation, it's better to keep like a standard and keep it standardized. Whenever there's a problem, you can look at how it was done and fix it. Because imagine if you, instead of using like the first one, you're having problems and it's actually the yellow one, this one right here. And the first cable there isn't the blue one, it's the pink one. So you start here. Well, you start with this one, and wait, it's not this one, not this one, not this one, not this one, and wait, it's not any of those. And then you go to the next one. Okay, it's not that one, not that one, not that one, and then you go all the way down to pink. So now you're second guessing like, how's the whole installation done? Is it done correctly? So it's easier to just do it in a standard, and all the fiber the that we sell, like the trunk lines, are in this standard. So you're not gonna have any issues when doing installations that the colors are different to what you're used to. So let's just keep standardized, let's keep it clean, and it will be better for you in the long run whenever you have to go back and do like repair jobs or connect other stuff. It's easier for you to keep this in mind. Well, that'll be all. Thank you for joining us today. I hope you had a an informative presentation. I hope you learned something. Yeah, sure. I'll send you the presentation. Can you send me the of course, I'll send you the presentation. Can you help me with your email? Uh, sure, I'll send you the first presentation, Fernando. Well, that'll be all for today. Remember, on the 30th of this month, we're having another continuation to this Fiverr presentation. We're doing installation and best practices. We're also going to teach you a little bit about the math when you're doing installations, so you can make sure your onus and all of these are in blinding each other with the noise, or they're not sending like too powerful of a signal. So don't forget to join us for next presentation. It's gonna be a little more technical. So maybe you wanna write something down. It's gonna be uh, quite technical heavy with numbers. We're gonna do a little bit of math. So yeah, be prepared for that one. Well, thanks for joining us again. I hope you had a good experience. Um, we'll see you in the next one. Have a great day.